Hey guys, this is Miss Latours, and we're over here at the Mount Juliet Library, and we're in the process of wrapping up our solar system series. It's just like the traveling Wilburys once said, we're heading to the end of the line. Well, it's all right, even if the sun don't shine. Well, it's all right, we're heading to the end of the line. All right, I'll shut up. Your ears are probably bleeding now. But in this case, Neptune is the end of the line. Now, when Pluto was a planet, Pluto was usually the end of the line. Well, what do I mean by usually? Well, because it's got such a weird orbit, okay? Pluto sometimes would cut ahead of Neptune. In fact, between 1979 and 1999, that's the way it was. And then again, Pluto kicked itself out. Then in the year 2227, Pluto was going to cut ahead of Neptune. Now, how can this possibly be? Well, I guess it has to go back to the manner in which the whole entire universe was created by way of something that we call the Big Bang Theory. Now, the Big Bang Theory says that everything that exists in the universe at one time was part of a singularity. And it took about 14 billion years for this singularity to gradually expand and move further and further out till they're at their current locations. Think of the singularity as being the starting point at which the universe begins. Now, what caused this rapid expansion? Could have been an explosion. Who knows? Scientists do not agree on this, but we do agree from a scientific point of view that the Big Bang did start about 14 billion years ago. This does not mean that it has to contradict creationism, guys. We've done a number of lessons where we've seen creationism and the Big Bang can coexist with each other. Two different ways of looking at it is one, it starts at a starting point and gradually expands outward, but the other one is like a timeline. You could see how the Big Bang is happening, and it's going to give us different markers of time so that we're able to understand what's going on. This picture over here is going to show us our solar system. The sun is the star because it had enough mass to generate a thermonuclear reaction that's going to start the fusion process. However, the planets didn't have enough mass, and as a result of that, they never generated that fusion process to become stars. They would just become planets. Now, you see over there from the left-hand side, there's an asteroid that's getting gravitationally attracted to the pull of the sun. That's what we think Pluto was. Pluto was not formed with all of the other planets. Rather, Pluto was an asteroid that got too close. Gravitational pull of the sun grabbed onto it. It collided with that planet we believe that existed in between Mars and Jupiter. Bang, went out, hit Uranus. You know the rest of the story from the previous lesson. Okay guys, so like all of the other Jovian planets, Neptune is a giant. It's got a long period of revolution, takes about 165 years, but a short period of rotation, only about 16 hours. It's a gas giant. It's made up predominantly of hydrogen, helium, and nitrogen. Nitrogen is the reason why it has that blue color. As you can see when we compare it to planet Earth, it's huge, all right? It has 14 moons. However, 12 of them were discovered as a result of the expedition of Voyager 1. It's about 30 AUs from the sun itself. Now, Neptune was going to be the very first planet that was ever going to be discovered by way of using math. Okay, what do I mean by that? Well, what I mean is this, okay? There's something called a perturbation. A perturbation is kind of like a little bit of a blip in the orbit of a planet. Now, this should be the normal revolution of Uranus going in a relatively straight line. That's normal. But every so often, it does kind of like blip. It changes its direction for a little bit, then goes back to its original orbit. It's that blip, it's that blip perturbation that's going to give us the idea that there's something beyond Uranus that's actually pulling it out of its orbit. So what they did in the year 1821, they mathematically theorized that there was another planet beyond Uranus that was creating the perturbation. If you take a look over here, the blue arrows is the direction that the orbit should go, but in reality, the red arrows is going to show us the perturbation of that. That means something is happening beyond the orbit of that planet that's going to cause the orbit to shift, and that's the way we discovered Pluto. Now, Uranus is discovered in 1781. The perturbations of Uranus are discovered in 1821. This is going to allow us to theorize that there was another planet out there that we now call Neptune. Take a look at this. In 1846, okay, about 25 years after we made the theory about the perturbations, we finally see Neptune. And that's the way it looked over there. Now take a look at the way we're able to see Neptune as a result of Voyager 2. Absolutely amazing, okay? What makes Neptune so fascinating is it's got a series of dark spots all throughout the planet. We believe that these dark spots that come and go in different locations are a series of ongoing storms that are happening across the surface of Neptune. These storms have got wind speeds of about 1,300 miles per hour. So like all the other Jovian planets, Neptune has got rings, and guys, that's pretty much it. That's the end of the known planets. Next week, we're going to take a look at the dwarf planets. But for now, we've now reached the end of the line.
Don't you dare!
I'm sorry, I have to. Well, it's all right, riding around in the breeze. Well, it's all right, you get to live the life that you please. Well, it's all right, even if the sun don't shine. Well, it's all right.